All right, so very Sunday good morning, students. Quickly, let's just check the audio. Let us quickly check the audio. Sunday morning. Okay. All right, so very Sunday good morning, students. Quickly, let's just check the audio. Yeah, it's all working fine for us. So today we're gonna take up this chapter in length. The chapter which is called as alcohol, phenol, and ether. How we will do is we'll spend some good time here. We'll go through each and every concept, certain mechanisms that are covered in the chapter. There are total two mechanisms that you get, other three. One is going to be the formation of alcohol by hydration of alkenes. Second is going to be the conc H2SO4 dehydration at 443 resulting in alkene. And one is going to be conc H2SO4 dehydration at 413 resulting in ether. So these three mechanisms are typically to be covered here in this chapter. What you will come across are some reactions which needs to be taken into mind because they could be named reactions also. Something called as Riemann-Tiemann reaction covered in phenol. Something called as oxidation of phenol, bromination of phenol. Phenol has some good reaction. Then Williamson synthesis, what happens if a 3-degree halide is there or a 1-degree halide is there? What is the key difference when we come to Williamson synthesis or the reverse of it as well? Williamson synthesis is a formation of ether. We will talk about the cleavage of ethers as well in the context of ethers. Primarily in terms of alcohol, once we talk about the HBO reaction, hydroboration oxidation, which is actually the anti-Markovnikov addition of water to the alkene. We talk about copper 573 Kelvin, which is called as dehydrogenation reaction. We talk about some great reactions, basic terminology, primary alcohol, secondary alcohol, tertiary alcohol. What does it mean? 1 degree, 2 degree, 3 degree. What is their significance? How they behave? And all these things in this single chapter. Remember alcohol, phenol, and ether. When we see 60-40 ratio, which is a small video I made almost a week back or so, that 40% of the chapter giving you 60% of the marks is something which is this chapter, which is alcohol, phenol, and ether. Two key chapters in organic, which is something called as, what should I say? Alcohol, phenol, ether, and aldehyde ketones and carboxylic acids. These two are the key chapters. Most important of them, alcohol, phenol, ether, and aldehyde ketones and carboxylic. A lot of named reactions in these chapters. Maybe the next chapter has more named reactions, aldehydes, but this chapter also has a lot of good context to work on, to see it, and everything like that. We'll start with the basics of it. I'm sorry if this audio disturbs you a little, but we will be moving ahead in a way that we keep on noting down things. Now onwards, the notes also will be provided to you in the caption of the video after the video is complete. And then you can check out the NCRT, highlighted NCRT also for a quick revision of your chapter. Again, let me tell you, when we talk about 60-40 ratio, alcohol, phenol, ether plays a very big role. But eventually, I have to, disappear at times to make you copy. So that should not happen. I'll just reduce a little of my size today so that I don't have to disappear myself again and again. So when you have to copy a little part of the board, I will only capture. Right? So let us just quickly start with it. Disappear. Good one. All right. Let us quickly put the heading. It's going to be a little long session, but we'll cover everything. If it is going very long, we'll split into today morning, today late evening, or tomorrow morning. Okay. Now, alcohol, phenol, and ether. And just keep your NCRT also handy with you. My sincere request. because that will help you quickly. You know, what I've done is that I have kept my NCRT with me here, and I request you also to keep your NCRTs with you as a part of this chapter reading, because a lot of context which we will relate with the NCRT, you will quickly mark the NCRT here and then we will proceed. Right? So it's going to be a parallel thing of NCRT and notes that are a lot of value to your own learning system also. Probably right. So now quickly we go to something which is called as the notes for alcohol, phenol and ether. Okay. And the first thing I want to talk about here is something which is called as the degree of alcohol. What is called as primary alcohol, secondary alcohol, tertiary alcohol, methyl alcohol? What role does it play here? We want to talk about here as the first thing, which is called as degree of alcohol. Now, in my very simple layman terms, the way it writes is the carbon to which OH is attached. The carbon to which OH is attached is itself attached to how many carbons? Is itself attached to how many carbons? Directly. Directly is the most important word here. Directly is the most important word here. I'll tell you the examples also. But how it goes is the carbon to which I am attached, I am the OH group. Remember, alcohol is the OH functional group. OH functional group. Then phenol is something which is a renowned compound, phenyl with an OH. Phenol is phenyl with an OH. And again, ether is a class of compounds which is called as RO, R dash, or it could be AR as well, aryl ethers. We will talk about it. But coming back to the degree of alcohol, because it's going to be the same degree of halide, degree of aldehyde, same stuff happening around. What? That the carbon to which I am attached is itself attached to how many carbons? Example, example. Say for example, I am CH3OH. So the carbon to which I am attached is not attached to any other carbon. The carbon to which I am attached is not attached. See, the carbon to which I am attached is not attached to any other carbon. Is not attached to any other carbon. So this is the case where I call it as a methyl alcohol. This is called as a methyl alcohol. This is called as a methyl alcohol. Methyl means I am the only one present. Methyl alcohol. To be honest, methanol. We will talk about those nomenclature also a little in this chapter. Methanol. Alcohol with a single carbon. Right? However, if I give you another example, if I give you a little another example, I talk about it, which is called as the next carbon, wherein say it's gonna be CH2OH, and I am connected to one more carbon. Now this carbon could be connected to n number of carbons. Hell does it matter? It doesn't matter. What I want to say here is the carbon to which I am attached is directly attached to how many carbons? Sir, one carbon. The carbon to which I am attached, probably it is going to be repetitive for you, but it is important to understand right away. This will add a lot of value once you move forward. What it says is the carbon to which OH is attached, the carbon to which OH is attached is directly attached to one carbon atom, and therefore this is gonna be a primary alcohol. This is 1 degree or primary alcohol. Very important. This is gonna be 1 degree or primary alcohol. That is, the carbon to which I am attached is directly attached to only one carbon. Right? Good one. Then what next? Next here is, sir, if it is a 2 degree, how does a 2 degree appear like? Okay. How does a 2 degree appear like? Sir, it's gonna be CHOH. The carbon to which I am attached is directly attached to two carbons. The carbon to which I am attached is directly attached to two carbons. So this is gonna be a 2 degree alcohol. Or we can say it a secondary alcohol. Right? Secondary alcohol. And last but not the least, the carbon to which I am attached is directly attached to three carbons, and therefore this is called as a tertiary alcohol. This is called as a tertiary alcohol. Tertiary alcohol. Right? Which is 3 degree. Now quickly take a glimpse of these three things. Primary attached to 1, secondary attached to 2, tertiary attached to 3. Just a little example of it. In terms of hydrogen also we can define it. In terms of hydrogen also, degree can be identified. Degree can be identified. How do I do that, sir? How do I do that? For example, if it is CH2OH, it's gonna be two hydrogens, and two hydrogen means it's a primary alcohol. Two hydrogens where? So two hydrogens on the carbon to which OH is attached. Number of hydrogens in terms of number of hydrogens where on the carbon on which OH is attached. Number of carbons on which the OH is attached. Right? CH2OH is a primary alcohol. Then what do I say? If it is only one, which is CHOH, is gonna be a secondary, one hydrogen. It's gonna be a secondary alcohol. And then last but not the least, if I have no hydrogens, which is COH, that is CH, no zero, which is zero hydrogens, zero H, I call it as a tertiary alcohol. Now this is gonna be my first concept in this chapter. right? I hope this is a little clear to you, not a problem at all. Number of hydrogens also, it can be figured out. True. Now, the other terminologies of alcohol also should be known. Other terminology in alcohols is something which is called as number of OH groups. It says depends on the number of OH groups depends on the number of OH groups present in a molecule in terms of it could be monohydric alcohol, number of OH groups. Remember, it's gonna be number of OH groups. Number of OH groups. So its first is gonna be monohydric. Monohydric alcohol. And mono means single OH. And then single OH group present. And then it's gonna be anything trihydric, bihydric, polyhydric, depending on the number of OH that are present. Say, for example, trihydric. Trihydric means three OH groups present. OH groups present. As an example, it's gonna be carbon, 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 which is say CH2, CH, CH2, OH, OH, and OH. So this is gonna be a trihydric alcohol, or we can say a polyhydric alcohol with number of OH groups is number 3. So this is something the definition depends on the number of OH groups that you have. Right? Right? But now, since I am telling you what is the degree, it is very, very important, my dear students, to draw a flow chart on how this information flows. Right? Now, you people come to a blank page and operate in the landscape mode. People quickly come on a blank page and operate in the landscape mode. A little bigger picture. This is my portrait. My selfie comes in portrait. Now, selfie can come in landscape also, right? But I want you to operate in this landscape mode, which is like a little bigger side of the page, right? Come to a fresh page because I also am coming to a fresh page only. The remaining portion of the page, we will use it a little later, but we'll come to it, right? And put the heading because I've just told you the degrees. So this is something which is really important that we should talk about. Put the heading as oxidation reduction cycle. Oxidation reduction cycle. Oxidation reduction cycle. Little sorry for this, but okay. Oxidation reduction cycle, the most important component of these two chapters, what you're dealing right now. So the lowest member of this group is called as alcohol. It starts with alcohol only. Okay. It starts with alcohol, which is something OH group. I'll make it two stages. Sir, it's gonna be a 1 degree alcohol, a 2 degree alcohol, or a 3 degree alcohol. Now I know the degrees. That is why I'm taking this concept at priority. 1 degree alcohol with OH and only single carbon. 1 degree alcohol, quick representation, sir. CH2OH. 2 degree alcohol, sir, CHOH. 3 degree alcohol, COH. Quick representation, right? 1 degree alcohol, CH2OH. When it undergoes oxidation, very, very important, oxidation, it forms aldehyde. CHO. 1 degree alcohol 1 degree alcohol on oxidation gives you CHO. Aman says, Pranam Sarji. Aman Pranam. Very good morning, Sunday morning. But Pranam. Huh? Okay. 1 degree alcohol on oxidation gives you aldehyde. Most important. What could be the reagents per se here? Sir, my reagents could be PCC, CrO3. We will talk about these reagents in this chapter also. We will talk about them, right? Now, this oxidation could also be pronounced as dehydrogenation. Removal of hydrogen is called as oxidation, right? So now copper 573 Kelvin, although it is called as dehydrogenating agent. This is something which you should note it below this table, but we will take a note of it. PCC, CrO3 can be your oxidizing agents. You become aldehyde. Whereas with the same reagent, my 2 degree alcohol my 2 degree alcohol becomes a ketone. Very, very important. Very, very important. Very, very important. It my 1 degree alcohol becomes aldehyde, my 2 degree alcohol becomes ketone. And rather, my 3 degree alcohol undergoes elimination. When I subject it to oxidation, it undergoes elimination. And what does it form? Undergoes elimination to form alkene. What does it form? It forms alkene. Very, very important, guys. Very, very important table. Solves a hell lot of problems for you. Hell lot of things for you. I'm telling you that. Okay. Right. Aman is very much interested in Vishesh. Vishesh, from where are you? Which part of India, Vishesh? Aman, which part of India you are from? Okay, so he has a question to Vishesh. He doesn't have a chemistry question. He has a location-specific geography question. Okay, which geography you come from, Vishesh? Aman, which geography you come from? Okay, anyways, aldehydes, ketones, and carboxylic acids. Sorry, aldehyde, ketones, and elimination, which is alkene. Right. Now, if I oxidize aldehyde, which is gonna be my next chapter question, if I oxidize aldehyde, I get the carboxylic acid, which is going to be COOH. Okay, Aman is from Bihar. Okay, thank you, Aman, for the information. I oxidize aldehyde, I become acid. So it's going to be alcohol, aldehyde, acid. Alcohol, aldehyde, acid. This is going to be my oxidation cycle. And how do I do that? So there are 2-3 reagents. Something is called as KMNO4, something which is called as K2Cr2O7, dichromate and permanganate ions. And ketones, once I oxidize, there is no oxidation, only rigorous oxidation possible. Only rigorous, or we should say vigorous. Only vigorous oxidation is possible. Only vigorous oxidation is possible. Right? Only vigorous oxidation is possible. What your points are? Only vigorous oxidation is possible. And that also results in the formation of acid. Acid will be formed but with lesser carbon. That also we will talk about in the next chapter per se. Acid formed but with lesser carbons. Acid is formed but with less carbons. Lesser carbons. We will talk about this concept also. Actually, the ketone, if it's a 5-member ketone, it breaks down. So it becomes 3 and 2. So propanoic acid and ethanoic acid will be formed. Your pentanoic acid cannot be formed from the oxidation of ketones. Right? Now, this was my oxidation cycle. Alcohol to aldehyde, aldehyde to acid. There's a quick twist to it. I could convert alcohol directly to acid also. Most important, my bacha party, alcohol to acid directly, quickly, any input from you. Alcohol to acid directly by using those same reagents, which is called as alkaline KMNO4 or acidified K2Cr2O7. K2Cr2O7 or Na2Cr2O7, dichromates or permanganates. This is very important. My acid could go directly, my alcohol could go directly to acid. Very, very important. Anurag, hi, good morning. Right? But this is all of my oxidation cycle. All of my oxidation cycle. Okay, alcohol to alde, alde to acid, alcohol to keto, keto to acid again, 3 degree to absolutely nothing. All you see on the screen is the oxidation cycle. Very, very important. I'm telling you, this solves a lot of questions. We discussed that on the way ahead also. Now, in the same diagram, something which is called as reduction cycle. Something which is called as reduction cycle. And there you see that your aldehyde could get converted to ketone. I'll just quickly share it a little down. You also should be able to accommodate in the same diagram right? Elimination. This was all oxidation as I talked about. Now something which is called as reduction. My aldehydes can be traced back to alcohol. Most important, most important. My aldehyde could be traced back to alcohol. Aldehyde reduction to alcohol. Reduction. And that the reagent is called as NaBH4 or hydrogen in the presence of nickel or hydrogen in the presence of platinum or hydrogen in the presence of palladium gives me aldehyde to alcohol. Also gives me ketone to 2 degree alcohol. The same reagents for both aldehyde to aldehyde to 1 degree and ketone to 2 degree. Aldehyde to 1 degree and ketone to same reagents to follow. Most important concept. Same reagents to follow. For this also, for this also. Depending on where do we start. If we start from 2 degree, we get secondary alcohol. We start from 1 degree, we get primary alcohol. Right? And now, sir, if I talk about a direct conversion of acid to alcohol, it's gonna be LiAlH4. Straight away, one step conversion I get from acid to alcohol. I'll reduce the dome shape. Yes. Acid to alcohol directly. Quickly, we will work on this flow chart. It's gonna be very, very important for you. acid to alcohol directly, it's gonna be through LiAlH4. LiAlH4, which is lithium aluminium hydride, a strong reducing agent. It's a strong reducing agent. Strong reducing agent. Alright, it's gonna be a strong reducing agent. Got your point? So this is how this diagram gets completed. I know it is behind me, but I hope you would have taken it. But okay, only for 5 seconds if I disappear myself quickly, if we pen it down: alcohol to aldi, alcohol to aldi, aldi to acid, alcohol to keto, keto to acid, 3-degree alcohol state T to alkene. And remember, alkene once we form can only be taken back to alcohol. Alkene once we form can only be taken back to alcohol by something which is called as hydration reaction. By something which is called as hydration reaction. By something which is called as hydration reaction. And what do I talk about? Hydration. How do I define hydration? Hydration reaction. And how do I define it, sir? Hydration is something going to be, either addition of H2O directly, or H2OH plus basically, or we should say B2H6, which is called as HBO reaction. We will talk about those one by one. Right, sir? So this diagram is utmost clear. Why I told you this diagram right away? Because when I talk about the chemical properties of alcohol, which will come in next half an hour, it will be the first property: preparation of aldehydes, preparation of ketones, preparation of this. So that all should be clear right away before you start the preparation of alcohol, because you would understand that okay, now alcohol is prepared, the next step, alcohol needs to get oxidized. There is nothing called as reduced form of alcohol. Alcohols do not undergo reduction because there's nothing smaller than the OH group in terms of bond. O is a single bonded structure here, OH is a single bond, therefore it is the smallest form. Most reduced form, nothing beyond that. Right? Diagram stands clear, very, very important, called as oxidation reduction cycle. Cool. So this part is now done. Now quickly let us talk about something which is called as my preparation of alcohol. One on one, very, very important. Preparation of alcohols. And the first stuff that we should always talk about is my Markovnikov's addition. Markovnikov's addition. Anybody in the chat box who could tell what is Markovnikov? Anyways, I'm going to tell you. But since we have good amount of people in the chat box, requesting somebody to tell what is going to be the Markovnikov's addition rule. Markovnikov's addition rule. And how does it function? Sir, I'll tell you that rule because although it's covered in class 11th hydrocarbons, but since we are dealing it for the first time here, let us cover that rule also. And how does it define it? Sir, it goes in a manner that the negative part of the addendum, negative part of the addendum, the negative part of the addendum goes to the side, goes to the side having having lesser number of hydrogens. This is something which is very, very important. Very, very important. In the next reaction, which is going to be my HBO, I'm talking about it repeatedly, which is hydroboration oxidation. Markovnikov happens. The same mechanism will follow. However, the end product appears as if anti-Markovnikov has been followed. But remember, Markovnikov said negative part of the addendum goes to the side having lesser number of hydrogens. Now, what is addendum? Addendum is gonna be my attacking species. What is addendum? Addendum is gonna be my attacking species. Goes to the side having lesser number of hydrogens. Technically, we will see this rule as in case of hydrogen. In case of hydrogen, comma, we can say rich becomes richer. Rich becomes richer. Rich becomes richer. Is the summary of Markovnikov. Sir, how does it go? Sir, it goes in a manner that CH3, CH double bond CH2 plus H2O in the presence of H plus. Now this H2O is H plus and OH minus. And we talk about the negative part of the addendum goes to the side having lesser number of hydrogens. Having lesser number of hydrogens. So what does it form? So it results in CH3, CHOH, then CH3. The negative part goes to the side having lesser number of hydrogens. So you see, already this had two hydrogens, this had one, it became richer. So in terms of hydrogen, the one with the higher became one more. The one with higher hydrogens got one more hydrogen, and that is we call as rich becomes richer. Right, sir? CH2 became CH3, something which is called as rich becomes richer. Now you see here, this results in the formation of alcohol. One more example that we have here, it says CH3, CH double bond CH2 plus H2O in terms of H plus. Rich becomes richer. Here it's both equal. Then what you get here is CH3, CH2, CHOH, and then it's going to be CH3. Also called as butane to all. Butane. 4 carbons, so butane to all. Butane to all. Right? This is a now what degree is the carbon? What degree is the alcohol? So the carbon to which I am attached. Anybody on the degree quick? The carbon to which I am attached is directly attached to two carbons. On the left one and on the right one, directly attached to two carbons. So it's gonna be a 2-degree alcohol. 2-degree alcohol or a secondary alcohol. Secondary alcohol. Fantastic. It's going to be a secondary alcohol. So the first reaction, which is called as hydration of alkene by water. Right? The first reaction that is called as hydration of alkene. Hydration of alkene. Now we are very, very smart people. The second reaction that goes for it is reduction of aldehydes and ketones. Now we know this and now we pen it down quickly. Reduction of aldehydes and ketones. Reduction of aldehydes and ketones. And how do we do that? And how do we do that? Reduction of aldehydes and ketones. Sir, now we know that RCHO, once I put my NaBH4, or if I put my H2Ni, or if I put my H2PT, all will result in the formation of RCH2OH, which is going to be a primary alcohol. Which is going to be a primary alcohol. However, if I talk about something which is called as RCOR dash, which is a ketone per se, and I use those same reagents that I have used above, what I get is as RCHR dash with a OH group. Ketones result in the formation of secondary alcohols. Ketones result in the formation of secondary alcohols. Secondary alcohols. And now we know this part, which is called as reduction of aldehydes and ketones, or reduction of carbonyl compounds. Reduction of category carbonyl compounds. Now, same reaction from acid also is what you already know, right? With LiAlH4, this reaction can happen, sir. Number 3, reduction from acids. Reduction of carboxylic acids. And where do we get this stuff? Where do we get this stuff? It is going to be RCOOH in the presence of LiAlH4. In the presence of LiAlH4 results in RCH2OH. Acid directly converts to primary alcohol. Acids directly convert to primary alcohol. Acid directly converts to primary alcohol. Acid directly converts to primary alcohol. Right? So this is gonna be my third preparation of acids. Third preparation of alcohol. Most important, the fourth preparation. The most important. The most important, my fourth preparation. Pen it down, it's gonna be most important, and I call it as from Grignard reagent. Two basic backup things here from Grignard reagent. Hi Sunil, you're saying hi, so my reply is hi. Hi Sunil, how are you? Happy Sunday morning. Already 10:15 on the clock. It's 10 o'clock on the Sunday morning. I just hope you are not feeling sleepy, right? Anyways, I'm not. I started a class a little late, uh, so that I don't feel sleepy in between the class, right? So, and I just hope even you are not feeling sleepy because alcohol is a chapter that in case you are feeling sleepy, it cannot be understood. And this is going to be very, very important chapter moving forward in your total syllabus also. Very, very important chapter. Okay, from Grignard reagent, which is Grignard reagent is called as RMGX. Remember, this is important. This is important. Now here it's basically a alkyl magnesium halide salt. It's gonna be R of minus and MgX of plus. This is most important. R of minus means a negative alkyl group, a negatively charged alkyl group, and a negative always loves which charge? I am negative, I would love positive. So that's positive loving species. If I love positive, you want to call me as a nucleophile. If I love positive, you wanna call me as a nucleophile. So in Grignard, the alkyl group acts as a nucleophile. Very, 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 very important statement in Grignard reagent, comma, the alkyl group acts as the alkyl group acts as a nucleophile. Acts as a nucleophile. The alkyl group acts as a nucleophile. And now how does it affect me? The important question is that, right? How will it affect me? Even if it's a nucleophile, how does it work? Now, what is Grignard reagent? So this reagent is used to increase the number of carbons. This application is really important. You can increase any number of carbons in the group by adding Grignard reagent. What we say, used to increase the number of carbons, used to increase the number of carbons, used to increase the number of carbons to the compound. I'll give you a quick recap, quick example here. How does Grignard function? Because that is going to be the time changing scenario for you. How does it work, sir? Sir, first of all, Grignard is a nucleophile thing. It attacks a nucleophile rather, so it is applicable to carbonyl compounds only. Most important. Applicable. Attacks on, attacks on, attacks on carbonyl compounds, carbonyl carbons. And how does it do it, sir? Why? Because of the electrophilicity. Because of the electrophilicity of the carbonyl carbon. Of the carbonyl carbon. Right? Electrophilicity of the carbonyl carbon. Now, how does it do it, sir? It does in a way that quickly now we see, say for example, I'm talking about CH3, C double bond O, CH3. For example, CH3, C double bond O, CH3, and I add CH3 MgBr. CH3 MgBr. What happens, sir? CH3 is minus, MgBr is plus. All of us know well that carbonyl, it goes towards the upper side, carbon plus and O minus. So this negative attacks the carbon, nucleophilic attack. This carbon, this negative attacks the carbon, the nucleophilic attack. The negative attacks the carbon, the nucleophilic attack. And what eventually happens, what you tend to make is CH3, C, CH3, Again, already a CH3 was there. Then O minus and MgBr plus. Now this MgBr plus is a very very good leaving group, and I tend to do what? If I just put H plus, then this leaves it, and what I tend to get is CH3, CH3, CH3 with a OH. And this is gonna be my alcohol formation. Remember, this is most important. Most, most, most important. You see here, what happened actually is that my ketone, this was my ketone, on addition of Grignard gives you a 3-degree alcohol. Most important assertion reason. What should I say? That ketones, very important point to note, sir. Ketones on addition of Grignard reagent, ketones on addition of Grignard reagent, ketones on addition of Grignard reagent results in the formation of 3-degree alcohols. Very, very important. Very, very important. This is a question of assertion reason. Similarly, had it been any aldehyde, quickly we do that here. Had it been any aldehyde, say for example, I'm talking about propanol, say CH3, CH2, COH, and I add something, say, called as the same reagent CH3 MgBr, therein CH3 minus MgBr plus, minus attacks the carbon, plus attacks the O. Then what happens here is, sir CH3, CH2, CHOH, CH3. The final answer, which was gonna be what? If I just quickly rearrange, it's gonna be CH3, CH2, CH, CH3, and then OH. Something called as butane. To all, we were just talking about it some 10 minutes back, and it's a 2-degree alcohol. Remember, my dear friends, that aldehydes results in the formation of 2-degree alcohol. Aldehyde results in the formation of 2-degree alcohols. Aldehydes on reaction with Grignard. Aldehydes on reaction with Grignard results in results in 2-degree alcohol. Ketone results in 1-degree alcohol, and aldehyde results in 2-degree alcohol. However, there is one point which is to be taken here. However, sir, what happens, sir, now? Sir, however, in case of methanol, a specific example of a single carbon aldehyde, also called as formaldehyde. Right? How do I define it, sir? Sir, it's gonna be HCHO. And then if I add CH3 MgBr, sir, it's gonna be CH3 minus MgBr plus. Same scenario, same scenario. Sir, how do I do it now? Sir, how do I do it now? Sir, it's gonna be CH2 with a OH, O minus, MgBr plus, and then you have CH3, which on H plus results in CH3, CH2OH, which is a ethanol, also a primary alcohol. Quickly pen it down, and you will realize, that it actually resulted in a primary alcohol. You may pen down these three reactions quickly so that when you pen down the summary, it is gonna be Grignard summary, Grignard reaction summary, and a beautiful thing to take it down from here, something which is called as, sir, if I am only formaldehyde will result in the primary alcohol, full stop. Any other aldehyde, on reaction will give you 2-degree alcohol, say secondary alcohol. And last but not the least, my ketone on reaction with this results in the formation of tertiary alcohol. I'll show you this in the NCERT also. Right? All right. Okay, I'm really sorry for it. Rudra says 3 watching. Not a problem, Rudra. Anybody, if even if 3 are watching it, 3 will crack the NEET exam. Not a problem. Right? Anybody watching any video dedicatedly will always have a high, because it's all in an academic video, adds a lot of value to your revision. In case you're watching it with full strength, you will crack the exam. In case you're watching it to, that way, it is going to be difficult. So even if it is 1 watching versus 3 watching versus 103 watching, hardly matters. Anybody watching should watch it in a way that it's an academic video. That is only my request. In case you are there in the chat box and watching it only for fun, you may please leave it, because it will waste a lot of your time. You are a NEET aspirant, you need to respect it. Right? You need to respect your own preparation strategy, your own time, your own strength, and your own weakness also. If alcohol phenol ether is your weakness, if organic you're a little weak in the organic, this is going to be a session that takes each and every point of this chapter and goes ahead with you. Right? Still, if you feel you already know a lot of it, you want to revise, you stay here. You don't want to revise, you may leave the chat box and start self preparation. Not a problem. But in case you are here only to see how many people are here, it will not add value to your preparation. Remember, your success is your ultimate goal. Right? Right. Your success is your goal. Your goal is not your friend's failure or your friend's success. Your goal is your success. All right, sir? Okay, very good. Grignard reaction summary, formaldehyde primary, and either aldehyde secondary alcohol, and ketones tertiary alcohol. On reaction with Grignard, which is RMGX, RMGX, and RMGX. Quick, right? I hope this is something which all of you have already pen it down. Now, here, if this is the point which is already done till date, done till here, let us quickly go back to the NCERT. We have done something which is called as preparation of alcohols. It is high time that we go to the NCERT, that what NCERT has for us till this point in the bucket. And then we talk about the physical properties of alcohols. Almost all of us know that alcohols, because of the presence of OH, results in the hydrogen bonding. So alcohols tend to have very high boiling point. We talk about it in the physical properties of alcohols and phenols. Quickly, let us go back to the NCERT. May I request all of you to have your NCERTs handy because that will add a lot of value to your preparation right away. Right. The chapter's name is Alcohol, Phenol and Ether. We know some things which is called as, we are here, classification of ethers are mono, di and trihydric. I told you it depends on the number of OH groups present, may be classified on how does it define as? So it defines itself as whether they contain one, two, three, or many hydroxyl groups. Hydroxyl is the nomenclature for OH. Hydroxyl is the nomenclature for OH. Sorry. Hydroxyl is the nomenclature for OH. Now I have this child writing OP, 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 OP. Zandeep says I have doubt. Zandeep, most welcome. Doubt is most welcome. But Unistar, it's thank you. OP is okay, not a problem. I got your comment. Not to repeatedly mention it, right? Now hydroxyl is a nomenclature for OH. So you have mono, di, tri, and poly. Poly means more than three. It could be in case of large organic compounds. Mono is very simple. Methanol, one OH, ethanol, propanol, any compound which we know common are all monohydric alcohols, right? Then dihydric with 2 and trihydric with 3. Moving forward, we have called as primary, secondary and tertiary. Again, the carbon to which OH is attached is directly attached to how many carbons. Not penning it down again here, but here remember it says in a manner that we should always remember. In these type, the OH is attached to primary, secondary and tertiary carbon atoms depicted below. How does it go? So primary has 2 OH, 2 hydrogens basically. Then secondary has 1 hydrogen and tertiary has nil. And tertiary has nil. We could take it from, from the perspective of your OH to 2H atoms. It's gonna be 1H atom and 0H atom, right? 1H, 2H and 0H. Important. In my notes also. Now comes the 2 and 3 typical words: allylic, vinylic. Basically, they are covered in this halogenes chapter, but we talk about here also. Allyl means to the carbon adjacent to the double bond. Remember, remember, remember. Allyl means to the carbon adjacent to the double bond. Again, al allyl means to the carbon adjacent to the double bond. This is gonna be my allyl carbon. The carbon adjacent to the double bond. Most important. Now, if I talk about hybridization, because NCERT talks about in that perspective, so I quickly need to go back to my notes and go back to that page where I had left some space before drawing that flowchart. Right? I have some space here, monohydric, where we were dealing with. I had told you to leave some space there. So let us go back to that same page and discuss what it eventually means. Most important concept, guys, because allylic will happen in case of halo also. Probably in case of amines also. Not in terms of aldehyde because anyways they are terminal groups, right? Okay, now what I'm talking about here is allylic. Allylic alcohol. Now, how does it go, sir? Allylic alcohol goes in a manner that, sir, it's gonna be CH, double bond CH, single bond C with the OH. Now, this could be Now you see here this combination. I want to call my this carbon. I want to call my this carbon as allylic carbon. How does it define it, sir? It is the carbon adjacent to double bonded carbon. Most important. Most important, carbon adjacent to double bonded carbon. Now, how do I narrate it in the other way round? Sir, I want to say it in a way. Now, I want to say it in a way. I want to say it in a way, carbon double bond carbon in a way that an sp3 carbon, remember, single bonded carbons are sp3. Remember, single bonded carbons are sp3. Single bonded carbons are sp3. Double bonded carbons are sp2. Double bonded carbons are sp2. So it's an sp3 carbon attached to sp2 carbon. Most important, I repeat it again. My allylic carbon is the sp3 carbon attached to sp2 carbon. Getting my point here? Allylic carbon is allylic carbon is sp3 carbon attached to sp2 carbon. Very good. And this is how you define the allylic position. I hope, sir, are the in-text questions of NCERT important? The name is Anya. Anya, they are most important. We will talk about them while reading this chapter also. But yes, in-text questions add a lot of value to your revision. Remember, for any exam, typically NEET, I want to talk about here your NCERT in text, NCERT solved examples, and NCERT exercise. These three components itself tend to give you 60% of the questions in your NEET exam. 60% of the questions in your NEET exam. What? Your NCERT exercise, your NCERT solved, and your NCERT in text questions, which are unsolved typically. So these three components add to 60% of your paper, probably more, not less than that. So if you're done with three, you are bound to get 60% means 400 plus marks in your NEET exam. And then comes your reading. If you've read the NCERT thoroughly, you get another 20-30% marks. And that is how, you take it one on one. The first thing is reading NCERT. You do it because then you can solve NCERT questions also. If you have not read the NCERT, you're already out of the league. Already, if you people have not started reading the NCERT thoroughly of chemistry or biology, physics a little less towards the NCERT reading side, then remember you are already half the battle is lost. In case NCERT reading has not yet started itself. Still you have time. We are just in the starting of December, 10th December today. We have 3 months, 4 months of time frame. Quickly start reading that. If you're a class 12th aspirant, Anya says reading NCERT takes a lot of time. Anya, there is no replacement, Mera bacha. There is absolutely no replacement to it. You have to read it, means you have to. And remember, if you're a class 12th aspirant, this is what I was talking about before you just interrupted. Then 12th class NCERT reading is a mandate for you, right? Now, the only thing that you have to do extra is 11th reading. 12th, anyways, you have to if you're a class 12 student. NCERT, now, anyways, it's a reduced syllabus. That video also I made for you. Your solid is not there. Surface chemistry, metallurgy, these chapters are not there. P block still an open statement on how much P block to cover, but we will see in the coming months how do other educators do it. And we will do that way. Not a problem. But my only concern for you all is your biology and your chemistry NCERT has to be thorough with you. Thorough with you. I will share with you my highlighted NCERTs that I used to take almost every year. Even the NCERT that we are dealing now, maybe next half an hour, it will be completely highlighted. So that way, now the allylic carbons are the sp3 carbons directly attached to sp2 carbons. Now back to the NCERT, sir. In these alcohols, the OH group is attached to an sp3 hybridized carbon adjacent to the carbon-carbon double bond. That is to an allylic carbon. Most important statement. Very important. Then we have benzylic. Benzylic is something which is called as CH2. Benzylic is benzene with the CH2. Benzylic is benzene with the CH2. Now this is also sp3 sp2 combination because this is sp3 single bonded and the benzene is sp2. However, difference is it's benzene. In allyl, it is not benzene. That is the differentiator. Allyl benzene is not involved. Benzyl benzene is involved. Right? Now, how does it say as OH group is attached to sp3 hybridized carbon next to an aromatic ring. sp3 hybridized carbon next to an aromatic ring. Difference between allyl and benzyl is what is the difference now? In allyl it is C double bond C with a carbon, and in benzyl it is benzene with a single bond carbon. And this is how the difference between allyl and aryl is what we not. Aryl is the same as benzene. No, aryl is phenol. We will talk about that. However, aryl is phenol. However, allyl and benzyl difference is really important because both are sp3 sp2 bonded. Very very important statement, sir. Both are sp3 sp2 bonded. Both are on sp3 carbon bonded to sp2 carbon. This is the similarity. This is the similarity. Right, sir? Now, allylic and benzylic alcohols can be primary, secondary, tertiary, hardly matters. Containing sp2, and sp2 means phenol is what we talk about. Single OH is your mono, 2 OH di, and 3 OH tri. Ethers which are asymmetrical ethers we'll talk about RO, R dash. Now quickly let us come to in-text question 7.1 which Anya was asking if it is important. It will take me hardly 30 seconds to all of us to quickly do this question. Again, I have to identify the degree, and how do I do it? The carbon to which I am attached is itself attached to how many carbons, or let us count the number of hydrogen atoms attached and we are through. So it's going to be CH2. It's going to be CH2. CH2 means I am a primary alcohol. Quickly, all of you. I am a primary alcohol. So it's going to be CH2. CH2. So I am going to be primary alcohol. The difference here is this is the left one is a conventional primary. However, the right one is technically an allyl alcohol. But allyl alcohol here is a 1 degree alcohol. 1 degree means the carbon to which I am attached is directly attached to one carbon. Directly attached to one carbon. Quickly, again, this is going to be my CH2OH, 1 degree primary. This is going to be CH, 2 carbons directly attached. So it's going to be 2 degree, 2 degree. Then we have to which I am attached. CHOH is again 2 degree. And then we have CH, see this carbon to which three atoms are attached, left, right, top, bottom, no hydrogen. So it's gonna be a 3-degree alcohol. It's gonna be a 3-degree alcohol. It's gonna be a 3-degree alcohol, right? This question stands done for all of us. Fantastic. This question stands done. So this is fantastic. Now, coming down, we have the nomenclature, which we will talk about in a little more once we are summarizing the organic chemistry. Common names, which is very, very important in this chapter, are phenol, cresol, catechol, and some names like this. These are very, very important nomenclatures. If you are penning it down in the notes, probably better that you pen it down right away. How do we do that? Single O is phenol, with methyl is cresol, with methyl is cresol. Now it could be ortho, meta, and para, metacresol, paracresol. So tolufenol is cresol. Probably by that name, how do we remember? Tolufenol is cresol. Tolufenol is cresol. Tolufenol is cresol. The best way to remember is tolufenol is cresol. Tolufenol are going to be ortho meta para. Already I have told you in my first organic class, the adjacent position ortho, next position meta, the farthest position is going to be my para. Right now 2OH is catechol. My neighbors a little far, resorcinol. Very far, quinol. These three names are to be penned down in your notebook. Are to be penned down in your notebook. There's something which is most important. Two OH together. Catechol. Neighbors, catechol. A little far, resorcinol. A very far, hydroquinone or quinol. Okay, catechol, resorcinol, quinol. Oh, I'm just next to you. Hi, catechol. No, I am a little far. A little far. Hi, resorcinol. Very far. Oh, quinol. So that way, some mnemonics you have to make and remember because these three names can be very common while putting questions in front of you. Very common, right? And then we talk about something which is called as very good. We have the structure of the functional groups, OH, olive lone pairs, that also we will talk about it. And the topic where we started with was something called as the preparation of ethers, is where we started this chapter. Quickly, let us scroll through it. Preparation of alcohols. The first one was from alkenes, and that was on the addition of H2O. Now, there's a mechanism to it, which we will talk about it here in next 5 minutes. But let us quickly scroll through the other methods of your preparation. We go to the next one. Hydroboration is what we have not done yet. Yes, from carbonyl compound, see, it is called as reduction of aldehydes and ketones. The flow chart is already made. And how do NCRTs define it? Very quick. By addition of hydrogen. The usual catalyst is a finely divided metal such as platinum, palladium or nickel. It is also prepared. Now what could be? H2PT, H2PD, H2Ni. Quickly. H2PT, H2PD, H2Ni. Got your point? So this could be the catalyst or NaBH4, sodium borohydride or LiAlH4. Total all the reducing agents list I got, sir. H2PT, H2PD, H2Ni, then NaBH4, also LiAlH4. So these reagents will give me the required result. And very simple, only one statement the NCRT writes, which all of you know very well. Now, what? Sir, that aldehydes yield primary alcohols. whereas ketones give you secondary. We know this, right? And then we say the reduction of carboxylic acids are reduced by LiAlH4, a strong reducing agent. I told you the same stuff, right? By LiAlH4, a strong reducing agent. Where did I take you that? Quickly rush to the notes again. We go to the same diagram and we see here that LiAlH4, the acid can directly be taken from acid to alcohol by LiAlH4, which is a strong reducing agent. Wow, my notes are updated. Wow. Right, sir? However, LiAlH4 is an expensive reagent and therefore used for preparing special chemicals only. Commercially, acids are reduced to alcohols by converting them to ester. Acid converts to ester, ester breaks to alcohol. Right? Now, how do you do it? Commercially, acids are reduced to alcohols by converting them to ester, followed by their reduction in the presence of catalyst. How do we do that, sir? First of all, I make you an ester here, and then ester, if I put hydrogen, the same reagent which is easily available, it simply breaks down to RCH2OH and then R-OH. You know, ester, breaking of ester is called as some sort of saponification where you get alcohol and acid, but here it is not that. Here it is reduction of ester. Here it is reduction of ester. This is very important. Very, very important. Right, sir? Oh, wow. The next method we have is Grignard. How do I do that? I have told you the mechanism also. Now, if it is HCHO, I get primary alcohol. If it is normal aldehyde, I get secondary alcohol. If it is ketone, I get tertiary alcohol. And even the NCRT takes no single time to tell you that you will notice that the reaction produces a primary alcohol with methanol, a secondary alcohol with other aldehydes, and a tertiary alcohol with the ketones. Very, very important summary. And then after this, my chapter takes me to preparation of phenol. So when it comes to preparation of alcohols, it is only this much. One question which we have left behind is obviously called as HPO reaction, and that we take it right away. So what I'm telling you here, that preparation of alcohols is limited to what is now there in your notes and not beyond that at all. Right? Quickly. Now we come to the mechanism first, which we had taken in the notes, but we need to take it from here also. Remember any mechanism in my syllabus. Let us go back to the notes first because we are completing those also. Quickly. Preparation was the first one here. Now, what should I say? Mechanism. Put that heading. Mechanism of hydration of alkene. Mechanism of hydration of alkene. Hydration of alkene to form alcohol. To form alcohol. Mechanism of hydration of alkene to form alcohol. And how do I do that, sir? Note, please note, 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 note. 2000, note. Ban, sir, already bind, sir, already bind. Okay. What I want to say here is mechanism of hydration of alkene to form alcohol. Remember, any mechanism will have typical will have typical three steps, and that is gonna be number one, protonation. Protonation will be a step where H plus is taken from solvent to start the reaction. Wherein the first step I do is I gain H plus. The first step I do is I gain H plus. That is called as protonation. My second step is gonna be my attack. It could be a nucleophile, electrophile, anything like that. Attack to form the reaction intermediate. And third step is always the reverse of the first step, which is called as deprotonate. And deprotonate means anything which you have taken needs to be given back also. Return the H plus taken in step 1. Return the H plus taken in step 1. Clear this is? Clear this is? Clear this is? Protonate, attack, and deprotonate. Same 3 steps for 99% reactions that you do in your syllabus. Same mechanism. Quickly to the NCRT back. To the NCRT back on how do I do that, sir? The first step is my protonation. The first step of mine is protonation. Mr. Khatri says hello. Mr. Khatri, hello. Right. Khatri Saab, hello, hello, hello. Hello, Khatri Saab, hello. Okay, quickly, sir. The first step is protonation. And how do I protonate? Sir, my double bonded carbon, Bittu says, can the J people see? Absolutely, you can. And rather, it's going to be a complete handhold NCRT revision where it's going to be very, very beneficial for you. Very, very beneficial for you. Okay, now quickly. My phone says only 2% battery. I need to put in my charger, but okay, after 2 minutes, the mechanism should go over. No, fine. So, how it goes, sir? I want to say it in a manner that double bonded carbon. Now, you see here double bonded carbon. I'll quickly tell you, sir. Double bonded carbon is electrons, right? Double bonded carbon are electrons. Electrons. Now, if I give you the electrons, if I give you the electrons, I remain only with a positive charge. I give you something, I give you my electrons. So, what I am remaining with? Point number one, when I give you electrons, comma, I am left with positive charge. Step number one, I am left with positive charge. Now, how does it go? Sir, it's gonna be, say, double bonded carbon. It's sort of like this, plus minus. You see here, plus and minus. Now, on this minus, the H plus attacks. On this minus, the H plus attacks. So, what you are left with is a H here with a carbon with a positive charge. With a H here and a carbon with a positive charge. Remember, the addition of this H is called as protonation. Is called as protonation. The next one, as I mentioned, is a nucleophilic attack. Nucleophilic attack means the lone pair tends to attack my positive charge. Nucleophilic attack is the lone pair attacking the positive charge. Nucleophilic attack is a lone pair attacking lone pair attacking the positive charge. Right. Lone pair attacking the positive charge. And how do I do that, sir? Now the oxygen, it's O gives the lone pair, so O gets a positive charge, and so O gets a positive charge. Why positive? Because O has given the positive charge, because O has given its lone pair. O has given the lone pair. Very, very important. I'm telling you, it's very, very, very important because O has given its lone pair, so it gets a positive charge. And last but not the least is deprotonation. And when it says deprotonation, I always want to talk about returning what I have taken. And how do I return it? Immediately the H attached to O can please go. Because in the first step, the H got attached to O. Now it is the time for the same H to go back and then you turn into alcohol. This is called as deprotonation, right? Removal of the H which was borrowed earlier. So this is gonna be my first mechanism. Same three steps: protonation, attack, and deprotonation. Sorted, sir. This one is sorted. Typically important. We have to include this in our notes as well. Yes, you have to, because I need to bring my charger as well. I'll take a 30 seconds of break here, but yes, the mechanism has to be in your notes. Why? Because the mechanism can be a question. The mechanism can be a question in your NEET exam. No. NCRT, if you are reading it, most welcome. But this mechanism will be a question in your NEET exam, and that is why it has to be seriously taken. You may pen this down. This is the new syllabus. Yes, this is the new syllabus. No doubt. Alcohol, phenol, ether, there is no reduction in the syllabus, and then you have to do it completely. Completely, you have to. Right? Right? The next reaction that I take is the last reaction here, which is called as HBO, but just 30 seconds as I bring my charger also. 30 seconds and we are back. Quick. In the meantime, you may quickly pen this mechanism down. Protonation, I take the H plus. Attack, the lone pair of hydrogen attacks. O gets a positive charge. To remove that positive charge, my H plus should go so that the positive negative neutralizes. So O gets a positive charge by donation of lone pair. To remove that positive charge, H plus has to go, is the summary of it. Simple, simple. To remove that positive charge, to remove the negative positive charge, H plus has to go to neutralize oxygen. Very, very important. 30 seconds and I am back. 30 seconds. Right. So is the mechanism copied? Quickly. Quick. Is it copied? Last 1% battery. And I plugged in the charger. Yoo-hoo! Yes, sir. Fantastic. Now I do it. The last reaction in terms of the preparation of alcohol. Okay, did we finally get what is the gist of the preparation of alcohol? What is called as oxidation, reduction, grignard, hydration. All that is a little clear in our mind. Yes, yes, because that is how the flow of the NCRT goes. That is how you have to take it and absorb the information also. Right? Now, the last step, last reaction that we talk about is HBO. Remember, hydroboration oxidation. End product is anti-Markovnikov addition of water. End product. But the mechanism is Markovnikov. Why? Because Markovnikov always told about the negative part of the addendum goes to the side having lesser number of hydrogens. Remember again, my Markovnikov rule says the negative part of the addendum. Quickly, Markovnikov. What does it say about? My Markovnikov's rule says negative goes to the side having lesser number of hydrogens, right? Having lesser number of hydrogens, right? Now, how do I do that, sir? How do I do that? Here the H is negative. Here the H is negative. Diborane reacts with alkenes to give trialkyl boranes. This is oxidized to alcohol by H2O2. There are two reagents involved. How do I do that? My end reaction becomes, sir, if it's gonna be say CH3, CH, double bond CH2 with B2H6 and H2O2. This represents my HBO reaction. B2H6 and H2O2, hydrogen peroxide is involved. This represents HBO. Remember, this represents HBO. So what happens is that the negative part, which is H, attacks here H and then BH2. Again, it further goes, it further reacts, but then same thing happens, and ultimately your boron is attached with the three alkyl groups, and then comes the H2O2 part. Remember, my dear friends, if H2O2 is not involved, remember, my dear friends, if H2O2 is not involved, my boron 1, 2, and 3, and for all the positions, it has the same hydrocarbon with which I started. The first position, the second position, and the third position. Boron. All single bonds. All single bonds. All single bonds. Very, very important. Right? CH3, CH2, and then what happens ultimately after H2O2, you add up to propane 1-ol, which is the anti-Markovnikov addition of water. Simply it says the addition of borane to the double bond takes place in such a manner that boron atom gets attached to the sp2 carbon carrying the greater number of hydrogen atoms. Now you see here the summary is clear right away. The BH2 group attaches to the more number of carbons, more number of hydrogens. The BH2 groups attaches to the more number of hydrogens quickly, that the boron gets attached to the sp2 carbon carrying greater number of hydrogen atoms. Most important statement, may please pen it down for your NEET 2024 question. Very, very important. Very, very. The BH2 gets attached to the carbon with more number of hydrogens. So where does H gets? To the less number of carbons. And that is why it is turning as an anti-Markovnikov rule in terms of the final product. Very, very important. NCRT line by line to be taken, my dear friends. The alcohol so formed looks as if it has been formed in the way opposite, in the way opposite to the Markovnikov rule. Most important statement of this chapter: has been formed. It looks as if it has been formed by the addition of water to the alkene in way to the opposite rule. Wow. So beautiful, so elegant, just looking like a wow. So beautiful, so elegant, just looking like a wow. Very, very important statement. Now, moving forward, even this highlighted NCRT I'll share with you. And these are the notes that has to be always there set up here. NCRT has to be, that the same Singham dialogue, Atamaji Satakli types. Your NCRT has to be in here. Atamaji Satakli, 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 Satakli. So NCRT has to be here. Great. Now, quickly moving forward, the preparation strategy for alcohol now goes over. Preparation of phenols, we will talk about it because presently we are in alcohols. So we'll try to summarize alcohols first. Okay. And then we have the physical properties of alcohols and phenols and whatever. Right. Now let us come back to our notes and we put the heading physical properties of alcohols. Physical properties of alcohols. So this part is here, physical properties of alcohols. I just hope that we are taking notes side by side. Anybody who has joined a little late, welcome to the class of alcohol, phenol, ether. We are planning to wind up this chapter today itself. It's almost 1 hour and 43 minutes where we started. Planning for a little longer session to be honest. But each and every important point of this chapter can be covered. Each and every NCRT line, the notes, NCRT notes, NCRT, a juggle between the two is what we are doing it. Right, sir? Now, quick, physical properties of alcohols. Now, sir, when it talks about physical properties, number one, quick, we talk about boiling point. And how do I do that, sir? Alcohols have the highest boiling point, sir. Quickly, boiling point. The next I talk about is solubility in water, right? The other I talk about is your with the branching, impact of branching. Ayushi says good morning, sir. Ayushi, it's 11, so yes, it's good morning. And then last but not the least, I also want to talk about the untouched concept of the melting point. The four properties, and we are through. Melting point. Now, anybody who knows alcohol for the first time, remember, anybody who has come, oh, there is something which is called as alcohol. Wow, so tasty, sir, so tasty. अच्छा 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 बेटे no, no, alcohol is injurious to health, remember. So now when we talk about something which is called as alcohols, let us always talk about one concept which is called as hydrogen bonding. 5 minutes of deviation from the main topic, but something which is very, very important for your concept. H bonding is the bonding of hydrogen, the bonding of hydrogen atom with other electronegative atoms, with other electronegative atoms. Sir, it is simply the love of hydrogen towards only three people. It is the love of hydrogen towards only three people. It is a guy with three girlfriends. Okay? Three girlfriends are dating. Apu says, hi, sir. Hi, Apu. Again, so in this scenario, H bonding, it is hydrogen's love, hydrogen's attraction is okay with three elements, and they are phone. They are phone, fluorine, oxygen, nitrogen. They are phone. Now, how does it happen? Why only these three? Why not the others also? We talk about in just 2 minutes from now. Remember, Kanishk says, hello, sir. Hi, Kanishk. How are you? Okay, phone. Now, how phone works? How phone works here is, sir, to form H bonding, conditions for hydrogen bonding. Why I am telling you here, although this is also in class 11, but since we're talking about alcohols, this is important. Conditions for hydrogen bonding. So there are only two conditions. The first condition says the atom should be highly electronegative. The atom should be highly electronegative. And what is the electronegativity order? So the order here is phone call. So the order here is phone call. Fluorine, oxygen, nitrogen equal to chlorine. Phone call is the order of electronegativity. Fluorine is the most electronegative atom in the periodic table. Fluorine is the most electronegative atom. Fluorine is the most electronegative atom in the periodic table. Right? In the fluorine oxygen. But the second condition is a little disheartening for chlorine, as the second condition says the atom should be small in size. Should be small in size. And therein the chlorine does not qualify. The answer becomes fluorine, oxygen, and nitrogen. And that is where this phone is coming from. So the attraction of hydrogen with these three atoms, fluorine, oxygen, and nitrogen, is called as H bonding. And there are typically two types of H bonding. There are typically two types of H bonding that we will talk about right after 5 minutes in phenol also. Two types of H bonding. One is called as intramolecular H bonding, intermolecular H bonding, and the other one is called as intramolecular H bonding, which we will talk about in detail in another 15 to 20 minutes, wherein we reach phenol just after 20 minutes from now. Okay, quickly we are ready for it. Intermolecular and intramolecular H bonding. So this is the story of hydrogen bond. Story of my life, searching for the right. Story of hydrogen, searching for its bond. Right? There's a track. Story of my life, searching for the right, but it keeps avoiding me. What is the track? Na 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 na. Shit, even I don't remember what the exact I'm talking about. But okay, coming back to something which is physical properties of alcohols. Yes, alcohols have high boiling point. Alcohols have higher boiling point compared compared to corresponding alkanes compared to corresponding alkanes, comma, haloalkanes. Indeed, aldehydes as well. Aldehydes, ketones. It has higher boiling. Oh, the light has gone. Then why did it turn off? Okay. Hmm. Okay. Just give me 5 minutes, but we'll just quickly check it out. Not a problem. The net is working, na? Okay. Net is working fine. Okay. I'll just quickly repair it. Fine. The power has gone here, but not a problem. Alkanes, haloalkanes, aldehyde ketones, and ethers also. And ethers, why? Because of the presence of H bonding. Because of the presence of H bonding. Because of the presence of H bonding. Point number one. It has higher boiling point. Alcohols have higher boiling point. Point number two, same stuff. Alcohols are soluble in water. Remember, lower members. We always write this language, sir. Lower members of alcohol are soluble in water. Are soluble in water due to the formation of H bonding. Due to the formation of H bonding with water molecules. With water molecules. The formation of H bonding. Since I'm able to form hydrogen bond with water, since I'm able to form hydrogen bond with water, comma, I am water soluble. Very simple. Since I'm able to form H bonding with water molecules, I am water soluble. That is it. Soluble due to the formation of H bonding with water molecules. But remember, as the size of alkyl group increases, most important, sir, as the size of alkyl group increases, as the size of alkyl group increases, comma, my water solubility decreases. Water solubility. Light is back. Decreases. Wow. Water solubility decreases. And how does it decrease? Water solubility decreases because the hydrocarbon part is water repellent. Most beautiful line. Hydrocarbon part is water repellent. Very, very important. Very, very important. Extremely important statement. The hydrocarbon part is water repellent. Last but not the least, not second last rather, impact of branching, sir. Branching results in decrease in boiling point. Branching results in decrease in boiling point. Branching reduces the boiling point. Why? Because with branching, comma, this is same for all the chapters. With branching, comma, surface area of the molecule decreases. Surface area of the molecule decreases. Surface area of the molecule decreases, comma, area decreases means van der Waals forces decrease. Van der Waals forces decrease. Van der Waals forces decrease. And therefore, the boiling point reduces. The boiling point reduces. Boiling point reduce. Last but not the least is my melting point, my dear children. And the melting point here, how do I define the melting point? The melting point is in a way defined as melting point in a way is defined as melting point in a way is defined as the better the packing, the better the packing in the lattice, which is actually the symmetry of the molecule, the better the packing in the lattice, which is say symmetrical molecule, the better the packing, comma, higher is the melting point. Higher is the melting point. So basically, this is more pronounced in case of phenol, say meta, ortho, and para. Para has the highest melting point. Remember, higher is the melting point. It is more pronounced in the case of benzene. So here we say that the para isomer, that the para isomer has the highest melting point. Has the highest melting point due to symmetry. And that's it. So they are the four beautiful physical properties which are common for all the chapters, which will be covered in all the chapters, and they are really important for all the chapters. Right? Right. I hope it is all penned down. Hydrogen bonding is what I took you a side stream and taken that. And now quickly I take you back to the best book in our syllabus called as the NCRT. Quickly, sir, the boiling point of alcohol and phenol increases with the increase in number of carbons. The boiling point decreases with increase of branching. Quickly, standard points. Boiling points decrease with increase in branching. Simple. Decrease in the surface area. Something which are already there in the notes. Yoo-hoo, I have taken that in my notes also, sir. I have taken that in my notes. It's there in your notes also. Right? Now, it is interesting to know that boiling points of alcohols and phenols are higher, namely hydrocarbons, ether, halo of comparable molecular masses. Why? Because in water, it says, oh, some lines are missing, it seems here. Or is it still loading? Not sure. The boiling point of methoxymethane is intermediate of the two boiling points. No. But I think maybe in your NCRT, can you take GOC too? Ane, we will take GOC as well. We will take all the chapters one on one, Baba. We'll complete the syllabus, everything on time for NEET. We are preparing for NEET 2024 and we will do that. Each chapter we have to take. Right? But I think I am missing some lines here. Probably it would be there in your NCRT. Or is it loading? I think. Now it's back. Sizing is the concern. Okay. The high boiling point of alcohols are mainly due to what are mainly due to the presence of intermolecular H bonding in them. See, when I talk about intermolecular, I always mean to say between the molecules. Between the molecules. Intermolecular H bonding is between the molecules H bonding. I am 1, you are 2. The bond between 1 and 2 is intermolecular. I am 1, the bond within myself is called as intramolecular. Between the molecules is inter. Remember, between the molecules is inter. And let me pen it down here only. Within the molecule is intra. Within the molecule is intramolecular H bonding. right? Within the molecule is intermolecular H bonding. Within the molecule intra, between the molecules inter. Right, sir? Then we have the solubility is due to the this due to is due to what quickly, sir? Is due to their ability to form H bonding with water molecules, and that is how it is done. Therefore, you are water soluble. Pink is not a good color, sir. No, not a good color, sir. A color is good, but it is not appearing good here, sir. Again, in water is due to their ability to form H bond with water molecules. The solubility decreases with increase in size. Why? Because the hydrocarbon part is water repellent. Why? Because the hydrocarbon part is water repellent. Right, my dear friends? This is all done. Now you see here the first question that talks about is, see, very very simple. First question, all are alcohols. All means all. See, it says pentane. Oh, the light has gone again. I'm really sorry. Pentane 1 all, butane 2, eth, prop, meth. The number of carbons are different. All are alcohols. Number of carbons are different. Right? All alcohols, difference in H. Difference in H. Difference in C, not H, C. Difference in C. Now you see here, meth has only one. So this is going to be the first order. This is my first thing. Methanol, then ethanol, then propanol. Now but has two. But 1, but 2. But 2 has a little branching. But 2 has a branching. But 1 is a straight compound. But 1 is 1, 2, 3, 4 and OH. And but 2, 1, 2, 3, 4 and OH. Branching is involved. So but 2 will have lesser boiling point. Branching, therefore but 2 has lesser boiling point. Branching, therefore but 2 will have lesser boiling point. Branching, therefore but 2 will have lesser boiling point. But 2 will have lesser boiling point. So basically number 3, then but 2 becomes my number 4, then but 5 becomes my but 1 becomes my number 5, and pentane becomes my number 6. That is how the order can be discussed. Very, very important. See, it says myth, eth, prop, but 2, but 1, pent. Very, very important. Very, 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 very important. The next is pentane, then normal alkane, aldehyde, ether. Remember, alcohols have the maximum, alkanes have minimum. So alkane, then ether, then aldehyde, and then alcohol. Alkane, ether, order can be taken down here. Guys, it's gonna be helpful for you. It's gonna be really, really helpful. The order of boiling point is alkane, greater ether, lesser than aldehyde, lesser than your lesser than your lesser than your alcohol. This trend will give you tons of questions while you practice tons of questions. NEET 2024 can definitely have a question from here only. Wow, paper getting leaked. Right, sir? So this is my physical properties of alcohol, phenol, and ether. Got your point? Got the point, sir? Did you get the point, sir? Yes, sir, we got the point, sir. Now I talk about the chemical properties of alcohols. Quickly, and in the second of time, let me quickly adjust the light so that we have it better. Quickly, just 30 seconds and we start again. A little better, not so sure, but still I could just adjust one light. So probably it can help us a little, not so sure. Disturbing audio for 30 seconds and then we start. Right? And then we talk about what I'm telling you is the physical, no, not the physical, now the chemical properties of alcohols. Two types of properties and we quickly shift to phenol. Phenol is very, very simple. Two types of properties, which is chemical properties of alcohols. Anybody in the chat box who could tell their weak point? Anybody in the chat box who could tell where you are struggling for the NEET 2024? Is it your first attempt, your repeat attempt? How do you think of NEET 2024? Can you crack it? You cannot crack it. What is there in your ideology? You can absolutely be very open in putting your doubts here. I'll be more than happy to assist you in getting prepared for the exam. Anyways, I'll be there through for the NEET 2024 along with your preparation. But it's just that how do we take it? Right? Now, chemical properties of alcohols has a very peculiar thing to take up, sir. Very, very peculiar thing to take up. May please note one on one. So, two types of properties. A little I need to increase the pen size. Just cooperate for a minute. How do I do that? How do I do that? I am here, okay. Only with the timing I have to. Sir, it's R O and H. Right? R O H. I'll just make a better O. Sorry. O and H. Now this alcohol has two types of properties. Alcohol has two types of properties. How to define them, sir? How to define them? The property number one is my RO minus and H plus. That is my OH bond breaks. That is my OH bond breaks. Remember, this is very, very important. Very, very important. When my OH bond breaks means, when my OH bond breaks means, in this case, you see, the alcohol behaves as acid. Alcohol behaves as acid. H plus. And this RO minus becomes a nucleophile. Becomes a nucleophile. RO minus becomes a nucleophile. Very important. In the second possibility, in the second possibility, in the second possibility, it is R plus and OH minus. That is my ROH bond breaks. In the second possibility, my ROH bond breaks. And with this OH minus replacing, this is more towards, this happens when I want to nucleophilic substitution reaction. Generally happens in case of nucleophilic substitution reaction. And that is where it comes as the main component. Because OH minus gets replaced by other nucleophiles. That is, my OH minus gets replaced by other nucleophiles. Most important, by other nucleophile is very, very important statement. Very, very important statement to all my dear children. OH minus gets replaced by the other nucleophile. Right? Now coming back to our normal pen size, we have two things to take up, sir. We have two things to take up, sir. Okay, and what are those two things? Very, very important. Dr. Harsh says, hi, Ananya. Dr. Harsh, if you are there to talk to Ananya, I think this is not the right platform. Probably you can go to some left swipe, right swipe app, which tends to waste a lot of time, right? And then Ananya will not help you clearing your NEET exam, Dr. Harsh. So let us focus on something which is called as the preparation of the NEET exam, right? I'm sorry. So now this nucleophile RO minus H plus acid alcohol behaves as acidic. And there comes the first question from this topic. Question: explain why. Explain. Question number one. Phenol, not phenol, I should say. It happens with alcohols also. But generally it is more pronounced in phenol. So I mentioned phenol. Explain. Point number one. Alcohols are acidic in nature. This is basically justify. The question is not explain. The question is justify. The question is justify. And I justify this by two reactions. This is the most important question in case you are a board exam writer this year, in case you have an exam, board exam, a 12th class aspirant you are presently, alcohols are acidic in nature, I have to justify, can happen by two reactions, sir. The first reaction is with sodium, wherein any acid on reaction with the metal releases hydrogen. The first reaction is with sodium, and the reaction is, how justify is that an acid forms a forms hydrogen gas on reaction with sodium metal. Therefore, therefore, alcohol is acidic. Point number one. So the reaction is in a way going in a way that, okay, my reaction is, I'm talking about say 3-degree alcohol. No, let me talk about 1-degree alcohol only. With Na will give me CH3, CH2, CH2, ONA plus H2. This is something which is called as my hydrogen is released. Right? Right? Alcohol is acidic. Sorted, sir. And the second reaction, this is my statement 1. This is my point number 1. This is clause A. And my clause B here is, on reaction with NaOH, comma, neutralization reaction takes place. Neutralization reaction takes place. What does that mean, sir? Neutralization reaction takes place. What does that mean, sir? It means when I'm reacting with the base as a neutralization, when I'm reacting with the base as a neutralization, oh, the light has come. The light has come. I'll just quickly readjust the lights in a second. But okay. On reaction with NaOH, the neutralization takes place. That means the compound reacting is acid. That means the compound reacting is acidic. How do I define that, sir? The same stuff, CH3, CH2, CH2OH, in the presence of NaOH gives you the same thing, CH3, CH2, CH2ONA plus H2O. It is the salt and the water which is formed. Salt and water are formed, confirming that the compound is acid. Confirms that the compound is acidic. Confirms that the compound is acidic. Very, very important. Quickly pen it down. Let me just quickly readjust the lights in a second. Right. So it's copied now. Yes, the lights is now better. Quickly. So this is something which justifies that alcohols are acidic in nature. Sorted, sir. This is something which comes as the first chemical property. And why? Because this is more pronounced in case of phenol. The next question is going to be justify why is phenol acidic. We will talk about it, but not here. In phenol, not in alcohols per se. Going back to the NCRT that we were into, quickly, sir, there are two types of properties that I get out of chemical properties of alcohols. Either what they do is they react both as nucleophiles and electrophiles, as we also talked about. Alcohols as nucleophiles, alcohol as electrophiles. But then, yes, we are here. Reaction of alcohol with water, alcohol and phenol with sodium, they liberate H2. With sodium, they liberate H2. With NaOH, they liberate salt and water. Metal H2, substance that liberates hydrogen. Substance that liberates hydrogen on reaction with metal must be an acid. Must be an acid. Must be an acid. Similarly, same statement I want to copy. Substance that forms salt and water. Substance that forms salt and water on reaction with a base must be an acid. Two factual points that prove that yes, alcohols are acidic in nature. Two factual points to prove that yes, alcohols are acidic in nature. Quickly, what they tell is that the above reactions show that alcohols and phenols are acidic in nature. And they are Bronsted acids. In equilibrium, we have three types of acids. Arrhenius acid that gives H plus, Bronsted acid that gives H plus, but in terms of proton we talk about, that they are able to give proton. And then Lewis acid, it can accept lone pair, it can accept lone pair. What can give lone pair is Lewis base, what can accept lone pair is Lewis acid. Here I'm talking about that alcohols are Bronsted acids, and Bronsted acids are which can give H plus, which can donate proton. What it says, they can donate proton. Exceptionally important points are alcohols are Bronsted acids. Very, very important. Very, 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 very important. My alcohols are Bronsted acids. Answer: Bronsted acids are those. Bronsted acids means they can donate H plus. They can donate H plus and then forms conjugate base. Acids form conjugate base and then forms conjugate base. Extremely important statement. Right, sir? And then forms conjugate base. Then we have acidity of phenols. We talk about what are more acidic, and then I will take you to the notes again before we come to phenol. We come down here, sir. This is all phenol. Phenol, I'm not talking about it because phenol I've not taught you for now. The next property is esterification. Yes, what is esterification? Alcohol and acid. Alcohol and acid react to form a fruity smelling compound called as ester. But we will talk about that in our notes only. Heading, put the heading acidity of alcohols. And there, the most important concept of inductive effect comes into picture. What is acidity? How do I define acidity? What is strong acid? What is weak acid? In next 3 minutes, you will be through this concept. How do I define it? Most important, sir, acidity of phenol. Quickly, quickly, quickly. Sir, the ease with which, pen it down in the most layman possible language so that it straightly gets embedded in your head. Straightly gets embedded there. The ease with which the alcohol can give, the ease with which the alcohol can give its hydrogen as H plus. Sir, it's very, very simple. It's very, very simple. It is very, very simple to all the beautiful people in the chat. It's ROH. It has to break. It is RO minus and then H plus. It's very simple, sir. It is with regard to my breakup with my girlfriend, which is hydrogen. If after my breakup I'm stable, I'm happy doing the breakup. If after my breakup I am stable, I am happy doing the breakup. Most important, sir, more stable the alkoxide ion, more stable the alkoxide ion, comma, more stable the alkoxide ion, comma, more stronger is the acid. Sir, if after my breakup I am strong, means I am bound to be a strong acid, right? After losing H plus, I am happy. Wow, what a beautiful world. So I am bound to be stable, correct? Is it not right? Absolutely, it is right, sir. No doubt in that. Right, sir? RO minus and H plus. So quickly, let us pen it down here. Let us pen it down here. Alkyl groups are plus I in nature. We've done this in the class 1 of the organic. If you have not seen it yet, quick take out some time to do that. But here I can suffice here itself. What do I say? Star mark that my alkyl groups are plus I in nature. Plus I means plus inductive, which means they push electrons away from themselves. They push electrons away from themselves. Which means, so just as an example, say for example, it is gonna be CH3O minus. For example, it's gonna be CH2O minus with another CH3. Then it's gonna be one more CHO minus with a CH3 with a CH3. And then last it's gonna be CH3, CH3, CH3O minus. Anybody quick answer? Anybody quick answer? How does it go, sir? How does it go? It's very simple, sir. More the number of alkyl groups, higher is the plus I. Plus I, plus I, plus I. More the number of alkyl groups, comma, higher is the plus I effect. Plus I effect. Again, how much? Plus I. plus I, and plus I. Plus I effect increases the negative charge on O. Why? Because electron, 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 electron. Plus I means electron. Plus I means electron. Plus I means electron. Plus I means electron. Plus I group increases. Plus I group increases the negative charge on O. Oh, the net is gone. Okay, it's stable for now. Plus I group increases the negative charge on O, therefore making it less stable. Therefore making it less stable. To summarize it, sir, to summarize it, remember, remember to summarize it, summary, summary is that Summary is that the plus I group decreases the acidic strength. The plus I group decreases the acidic strength. The plus I group decreases the acidic strength. And that is what is the output of this. Means for alcohols, comma, the order of acidity will be the order of acidity is 3 degree, say 1 degree greater than 2 degree greater than 3 degree. Most important, sir. Most important. The order of acidity. Right? It is most important. Quickly pen it down. Then plus I group increases the negative charge on O, therefore making it less stable, or we should say decreasing the stability. Any English that finds you well, you can pen that way down. Right? Quickly. Right? And now when you take I to the NCRT, we have to go because NCRT is something which we are reading simultaneously, sir. I take you to the topic which is called as the acidity of alcohols. The acidic character of alcohols is due to the polar nature, and electron releasing group increases. Important, sir. Very, very important, sir. An electron releasing group, which I am calling it as plus I. I am calling it as plus I. I, inductive I. Okay, right. So an electron releasing group increases electron density on oxygen, tending to decrease the polarity. This decreases, decreases the acidic strength, and therefore primary greater than secondary greater than tertiary. Primary greater than secondary greater than tertiary is gonna be your 2024 question. Got this point, sir? I got this point, sir. Yes, absolutely fantastic. I got this point, sir. Right? Right. However, it very clearly says that, however, alcohols are weaker acids than water. Remember, this is important, sir. Alcohols are weaker acids than water. And this could be because, alcohols can take H plus from water. So if it happens, then water tends to lose H plus. This reaction shows that water is a better proton donor than alcohol. Most important statements are most hidden statement of the NCRT. It very clearly says, sir, that water is a better proton donor than alcohol. Also, in the above reaction, we know that an alkoxide is a better proton acceptor then hydroxide, which suggests that alkoxides are stronger bases than alkoxides are stronger bases than hydroxides. Most important. Most important, please pen it down. You see, once you read the NCRT simultaneously, what value does it add? A lot of value additions in the system, a lot of value additions. Again, alcohols act as Bronsted bases also because it is due to the presence of unshared electron pair, which means, sir, to take a note here, alcohols can act as both Bronsted acid as well as Bronsted base. Wow, wow, beautiful concept. Bronsted acid as well as Bronsted base. Got this point, sir? Fantastic. And then we have something esterification we were talking about. And yes, we were talking about as CO, where the OH bond breaks, where the CO bond typically breaks, wherein then I become the nucleophilic substitution reaction. Right, sir? And that is these reactions H3PO4, dehydration, conc H2SO4. I have to talk about it right now. And then my alcohol goes over. Right? Understood this point? Anybody, any doubt till now? Anybody, any doubt till now? Because I will take these 5-6 reactions probably in the next class. But anybody, any doubt till now? I'll be more than happy to take any doubt. It's almost 2 hours and 40 minutes we have been taking this session. Phenol, one more session, and ethers finally a session, and we are through it. Phenol, one more session, and ether finally a session, and we are through it. Or phenol and ether can be a combined session also, which is going to be today only. Anybody, any doubt till now? Anybody, any doubt till now? No? Fantastic. Can we say it is done? Alcohol stands done. Sorted, sir. Please keep the NCRTs equally highlighted. The time I take your phenols, I will cover the remaining alcohols also because now it is more or less linked with it. Therefore, I am unable to process that. Again, the preparation of phenol and everything is here. Anything specific to alcohols is already been taken care. Any doubt, anything here, let me know quickly before we end this chapter. No, not the chapter, the session rather. Possible? No. Then let us take 10 more minutes and complete the remaining section. Not a problem. Summary, which is okay, this is the acidity. The next is CO bond breaking. Bond cleavage. And the first thing that happens here is with conc HCl. Alcohols, say which is ROH on reaction with conc HCl forms RCl plus H2O, but this forms with a turbidity. Turbidity. This is called as Lucas test. Happens in zinc. Zinc conc HCl. This is called as Lucas test. This is called as Lucas test, and it is actually a differentiation test, a differentiator test for alcohols between 1 degree, 2 degree, and 3 degree. So how it goes is that the turbidity is formed. Now there are three stances. Zinc conc HCl, the turbidity is formed. Now the formation of turbidity. Now the formation of turbidity can happen in three possible manners. One is immediately. Immediate turbidity is formed. One, after 5 to 10 minutes, turbidity is formed. And third, only after heating. Turbidity is formed only after heating. And that is how it differentiates between the three types of alcohols. Quickly to the NCRT, as reading is a mandate. Again and again, the same statement I've been telling you. Reading is a mandate, my dear child. So, reaction with hydrogen halides RH plus H2O. The difference in reactivity with HCl distinguishes them from one another, called as Lucas test. Alcohols are soluble in conc HCl and ZnCl2, while their halides are immiscible and produce turbidity. In case of tertiary alcohols, we got the solution, we got the answer. In case of tertiary alcohols, turbidity is produced immediately. Primary alcohols do not produce turbidity at room temperature. Means turbidity. Point number one, immediately. It's gonna be a 3 degree. 5 to 10 minutes, it's gonna be 2 degree. And after heating, it's gonna be 1 degree. It's 2 degree and 3 degree and 1 degree. Right? Got this point? Right, sir? 1 degree, 2 degree, and 3 degree. And this is called as Lucas test. Very, very important. The only test of distinguishing the various degrees of alcohol. Right? Test for distinguishing for various degrees of alcohols. Sir, immediate turbidity is 3 degree. After 5 to 10 minutes is 2 degree. And only after heating is 1 degree. Very, very important. Very, very important. Now, the next reaction in this range, the first is Lucas test. Second reaction is nucleophilic substitution. Nucleophilic substitution. And that is very, very clear, sir. Any alcohol which is ROH on reaction with PCl3, with PCl5, with SOCl2, the answer is going to be RCl. The reaction is going to be RCl. This is something where RO bond breaks, right? Mike's RO bond breaks. And that is where the Cl comes into picture. It is a nucleophilic substitution reaction used as the formation of haloalkanes. Used for the formation of haloalkanes. Used for the formation of haloalkanes. So this was simple for me, very, very simple. The last but not the least is the dehydration reaction. Dehydration of alcohols. Remember, my dear child, my conc H2SO4 is the dehydrating agent. Conc H2SO4 is the dehydrating agent. And this reaction takes place at two possible temperatures. The last concept for the day, for the session right now, and the rather important concept also. Dehydrating agent kind of two types of reactions. Number one is alcohol reacting with conc H2SO4 at 443 Kelvin. And second is same alcohol rather, reacting with conc H2SO4 at 413 Kelvin. Sir, at 443 Kelvin, how do I say it as? That one alcohol molecule minus one water. One molecule alcohol minus one water gives me an alkene. Results in the formation of alkene. I will talk about the mechanism also here in next 2 minutes. Alkene. Whereas in conc H2SO4, two alcohol molecules two molecules minus one water. In this it is two molecules minus one water, and that results in formation of ether. Results in the formation of ether. Results in the formation of ether. So now the first reaction that I talk about here is this step number one. Very important. This is the first step that we talk about, and the what do we say is, say CH3 CH2OH on reaction with conc H2SO4 at 443 Kelvin results in CH2 double bond CH2. Mechanism of ethanol to ethene. Right, sir? Again, switching back to the NCRT quickly, we have something which is called as reaction with phosphorus trihalides, PCl5, tribromide, which is PBr3, can also go to Br. Then we have dehydration to form alkenes on treating with H2SO4, but at what? 443 Kelvin. Sir, any mechanism will have three steps. Most important, sir, I already told you, your 2 degree will go to ketone and your 3 degree will go to alkene. Now, it says that your secondary and tertiary alcohols are dehydrated under milder conditions. At 443, it is going to be your primary. Secondary goes at 440 and tertiary goes at 350. Something important, something is hidden. Not every alcohols require. Primary alcohols require this. Not every alcohol means remember secondary and tertiary alcohols. Secondary and tertiary alcohols get dehydrated. Most important, sir, at milder conditions. Every point is important and therefore is being taken in the notes. Every important point should be there as a part of your notes also. Very important. Coming further, however, the ease of dehydration comes the main concept. The ease of dehydration of alcohols is tertiary, secondary, and then primary. NEET 2024. Ease of dehydration is tertiary, secondary, and then primary. Right? Simply because depends on the mode stability. It's here. Very important. Tertiary carbocations are more stable. Absolutely right. That is what I'm mentioning. depends on the stability of the intermediate cation. And it is already penned down there as a side note, can probably be a question also. Tertiary carbocations are more stable and therefore are easier to form. Tertiary alcohols are the easiest to dehydrate. And the steps are same, sir. One is protonation. The third one is deprotonation, formation of by elimination of a proton. Elimination of a proton is deprotonation. The first step is protonation. Same step, sir. Deprotonation. Right? And last but not the least, the second step basically here is the formation of carbocation. How does it happen? Protonation, I gain an H plus. I gain H plus. Then second is I eliminate water. Second is I eliminate water. It is the slowest step. I eliminate water. And then O has a positive charge. For this, I have to put the alkene now. Carbon gets a positive and then elimination reaction takes place. Suhas, very good morning. But I think it's good afternoon now, 12:30 on the clock. Okay, now the acid used in step 1 is released in step 3 to drive the equilibrium to the right. Ethene is removed as it is formed. Simple. I keep removing the product, more and more forward reaction happens. Ethene is removed as it is formed, drives the forward reaction in terms of Le-Chatelier's principle. Drives the forward reaction in terms of Le-Chatelier's principle. Right? Fine, sir. This is done. Then we have oxidation, dehydrogenation. I told you about copper. Now this is say. Now this is the reactions already done by us. Alcohol oxidation, aldehyde oxidation, acid. Strong oxidizing agents as acidified potassium permanganate are used for getting acids directly. CrO3 is used as an oxidizing agent. A better, better is PCC. Most important, already there in your notebook, sir. Already there in your notebook, sir. Please, please use PCC. It's very clearly says a better reagent for primary to aldehydes is PCC. Is PCC. Secondary alcohols are oxidized to ketones. Wow, I knew this. I knew this. I knew this, sir. Tertiary alcohols do not undergo oxidation reaction under strong reaction conditions. CC bond takes place and a mixture of carboxylic acids is formed. Vigorous oxidation, we talk about this. This is called as vigorous oxidation. Vigorous oxidation covered in next chapter. Covered in next chapter. Sorted, sir. Tertiary alcohols do not undergo oxidation reaction. Right? Then we have the undergo other elimination. Copper 573 Kelvin, I told you, they call it as a dehydrogenating agent. When the vapors of a primary or secondary alcohol are passed over copper, dehydrogenation takes place, while tertiary alcohols undergo dehydration. And that is where your alcohols chapter come to an end. Alcohol section of the chapter thoroughly comes to an end. Remember, my dear friends, copper 573 Kelvin. Copper 573 Kelvin is called as the dehydrogenation. copper 573 Kelvin is called as the dehydrogenation reagent. And dehydrogenation reagent is nothing but concept is same as oxidizing agent. Right? Is same as the oxidizing agent. Sorted, sir? Sorted, sir. And the next topic that we have is typically phenol and then ether. Right? So this stands done. Excellent thing done, sir. NCRT taken along with the syllabus, the most important part of it. And then maybe when we do the next class, we can complete this phenol and ether also. 3 hour session for alcohols, another 3 for phenol and ether, probably a little lesser, and we will be through along with the NCRT. The key chapter, most important chapter of class 12th, book 2, organic chemistry, is something which needs minimum 6 hours for notes and NCRT. 3 we have given right now, 3 probably in the next session, and we complete it. All right. Fine, my dear students. Thank you so much for attending this long session, but it's gonna be a lot of value thing to get added. Right? Take care. Bye bye. And good day. Sunday morning, Sunday afternoon now, Sunday evening, a little extra mile on the weekend, and we will be through. A little extra on the weekend and done. Right? Take care.